Welcome to Module 8, Talking to Your Data. Module 7 opened the pipe to the database. Now we put a face on it. A small app your teammates can click. Here is the bottleneck we are removing. If you are the only person who can run the query, every request still lands in your inbox, even after you learned the database. Streamlit is the shortcut. You write a normal Python script from top to bottom, and Streamlit renders it as a browser app with buttons, drop-downs, tables, charts, and messages. The one weird thing is that Streamlit reruns your whole script on every interaction. Click a button, move a slider, select a row. The file starts again from the top. That rerun model works because of three helpers. Session state remembers user choices. Cache resource keeps expensive objects like the database engine alive. Cache data keeps query results warm for a few minutes. The app should reveal one choice at a time. Connect first, pick a schema, pick a table or view, preview a safe number of rows, then visualize the result. Stage 1 is the connection. Put the SQLAlchemy engine inside cache resource. Read the connection string from Streamlit secrets and test it with a tiny select one query. Make the connection experience kind. While the test is running, show a spinner. If it works, show success. If it fails, show a plain English error instead of a stack trace. Stage 2 is browsing the catalog. Use information schema to list the schemas, tables, views, columns, and data types. The database already knows its own map, so read the map. A Streamlit data frame can be clickable. When the user selects one row, Streamlit reruns the app. Store the picked schema and table in session state, so the next screen knows what they chose. Stage 3 is preview. Once a table is selected, pull a small sample. Default to 100 rows, give the user a slider, and avoid accidental million-row queries. Show the SQL the app is running. That one detail builds trust, and it quietly teaches the user how their clicks become a query. Values still need parameters when they come from input. Stage 4 is visualization. The first useful chart needs 4 choices: a date column, a measure column, an aggregation like sum or average, and a time grain like month or quarter. Mechanically, convert the date column into buckets. Group rows by that bucket, aggregate the measure, and hand the result to Plotly. Line charts work well for time. Quarters often look better as bars. The Polish matters. Spinners, success messages, readable errors, a disconnect button, and visible SQL are not decorations. They make the app feel understandable when the database is slow or weird. This is the big shift. Before a teammate emails you, you run SQL and you paste a chart. After, the teammate opens a bookmark, clicks a basin, and answers their own question. Claude can scaffold the first version. Ask for a Streamlit app that connects to SQL Server, browses information schema, previews rows, and charts a measure over time with Plotly. Then iterate with Claude. Add a basin filter. Switch the chart to monthly bars. Wrap a timeout in a friendly error. Save the working pattern to memory and turn it into a reusable skill. This pattern generalizes past SQL Server. An Oracle warehouse browser can use the same flow: schema, object, preview, chart, export. The real work is hiding warehouse junk so users see only useful objects. Real tools use the same discipline. Cache the engine, cache the rows. And when natural language becomes database operations, keep reads easy, but treat writes with much more caution. Try this with Claude. Scaffoldapp.py. Connect safely, add a clickable schema browser, preview rows with a slider, add a Plotly chart, then package the steps as a reusable skill. That is Module 8. Next, Module 9 covers APIs, tokens, OAuth, and JWT. How systems talk to each other and how they prove who is allowed in.